Greetings, students. Hey, check. We're good. Greetings, my fellow geothermal students. Hey, welcome to Geothermal, Introductory to Geothermal Energy Systems. I'm Jonathan Bowe, your instructor, and just want to make sure that you have access to the course here. So you got your computer, you get your computer, and then we'll have you just open up your Firefox homepage, and you can access the home online University of Montana. You can go to my UMT.edu, and this is for the student version here. I need to go to the employee version, slightly different. And then we want to look at your Moodle course, and you see all the courses listed here, or all the CyberBear, course catalog, course search, academic planner, library, Cascade, box. And the box is good for confidential transfer of information. And then email. So let's take a look at your Moodle shell. To get in there, you need a Moodle non-net ID login or your student Moodle net ID login. And then we sign in. And there's your home page for a Moodle 3.0. It's the new version. We upgraded to the Moodle 3.0 on August 3rd at 11 p.m. at Mountain Daylight Time. But there's a few different things. If you have any questions about Moodle, there is some. You can get over here and you can get some some upgrade. Look for Moodle 101 for students. That's just a course that will help you figure out what's going on in the Moodle shell. So any questions about Moodle, please refer to your right hand bank over here, and you can kind of figure it out for yourself. And if you can't, then you can give Online Technical Support a call, and they can help guide you through that. And likewise, I'm happy to help guide you through that also. But I think you'll be able to figure that out for yourself. But let's take a look now at the special topics, geothermal energy, section 51, 75285 for fall of 2016. Here we are in the specific course, geothermal energy, introduction to geothermal energy systems. And once again, I'm Jonathan Bowe, and it's my pleasure to guide you through this course. And you'll notice down here, welcome to geothermal students, fall of 2016. Have a lot of content in this course, so you will at the very least get exposure to a lot of information. This course offers a great opportunity to interface with current resources / people from all over the world through the internet, which is a great resource. Geothermal is growing rapidly, and I feel like any background you can gain will be beneficial for entering the workforce. Please read the statement below, look through the syllabus and schedule, use email or discussion board to contact me. I have simplified this course and concentrated all assignments, labs, lectures, and tests into the central column of your Moodle shell. That's where we are right now. This is what I'm reading out of the central column. You notice here there's two side columns, and we've got this central column. Best wishes, Professor Jonathan Bowe. So we take a look down here, and the first thing we got is announcements. Let's see, any announcements in there? Aha! Got one discussion started. How hot is the center of the Earth? And if you wanted to add a discussion here, you just get in here, add a new discussion. But let's see what this is all about. How hot is the center of the Earth? Whoa! Some people think the plasma element located around the Earth's core is as hot as the surface of the sun. Now that's hot. Take a look here at it's just going to let me look at that. Oh, I'm going to have to paste that into my browser. Here's an article that you can add information in this respect, or you can just go ahead and type in your interests or your comments, your announcements, things you need to know about the course, things you'd like to see in the course. Okay. What this has to do with here is, let's see if it's going to do it for me.
Open up another page.
Sweet.
Making diamonds using radio frequency to create plasma, which is used to transmute carbon/methane into actual solid diamonds. We talked about this 2 years ago on the live radio show, and with Jim Lee from Climate Viewer, about using radio waves to convert methane and carbon into diamonds. Lucy in the Sky with Diamonds was the theme we all chose to use at the time. Skeptics came around and accused us of fraud, saying that it was impossible to use radio waves to create plasma, and further said it was impossible for plasma to do anything when it comes to building other elements or materials. Now we see that it not only is possible, but that companies are using the technology to create actual diamonds for people to wear. Wait a second. If they can make pure diamonds using plasma and carbon, doesn't that mean that naturally occurring diamonds are also made by Mother Nature via a plasma core in the earth? Diamonds made from plasma, proof that plasma energy is at the core of the earth. Not a solid metal. Carbon material which comes close to the plasma core of the earth must be bombarded with internal radio waves and excessive electron cascade, plasma energy, at such high temperatures. The natural diamond process must make huge diamond chunks near the plasma core, which then must fracture and distribute up into the mantle in the magnetically upwelling pressure caused by the superheated core melted magma material. The natural diamonds are found in certain coal-rich carbon deposits. The coal and carbon associated in the deep crust mantle region must be the area in which diamonds are caught up and then further pushed up over time in the deep layers of the plate. The fact that humans are using plasma to create diamonds is indirect proof, but substantial evidence that the core of the earth is energy, not solid. The main reason scientists think the core of the earth is solid is due to the reflection of seismic and radio waves off the interior core. Today's scientists are not taking into account the recent findings regarding plasma energy reflection of waves. The new findings prove that plasma energy reflects physical shock waves, and radio waves like a mirror. The US Navy has done the experiments using plasma to reflect transmissions, and Defense Department/Boeing has now developed a plasma shield that can deflect incoming blast shockwaves from explosions. Both the US Navy and Boeing using the new discovery of plasma wave reflection to counter both RF and physical shockwaves. This means that naturally speaking the plasma core of the Earth would indeed reflect seismic waves and radio pulses which are used to see inside the Earth. If scientists use seismic waves and RF to see the core of the Earth, when they look they see something solid reflecting back. The plasma energy would indeed reflect back as if it were a solid, when in fact it would be a fast rotating ball of superheated energy capable of melting every element, and capable of generating its own large electromagnetic field. This is exactly what we see on planet Earth. The core is hot and melts all things near it. The melting is not caused by weight of all the rock above the core. LOL at weight causing heat. The Earth has a large electromagnetic field extending far out into space. Again, a solid core of metal does not have its own internal magnetic field.
So this geomagnetics, the source of anti-gravity lifters, magnetic repulsion, so that we're going to see how the core of the Earth is so important as far as the plasma element. One of the four states of matter, gas, liquid, solid, plasma.
Nor does iron. Iron and metal are influenced by magnetism, but don't create huge magnetic fields of their own. Iron and metal are not automatically melted and rotating when you put a bunch of weight on top of those elements. Iron and metal. A solid core cannot account for the rotation of the layers above the core in the mantle. The only thing that is hot enough, carries its own powerful magnetic field, rotates/oscillates in one direction, feeds on power from particles in space, from the sun, and creates its own gravity. The only thing that meets all these requirements is plasma energy. Thus, after saying all the above, it should be obvious at this point that the core of the Earth is not solid. If it is not solid, and made of energy, then we must be feeding it with all of our artificially generated electromagnetic energy going to ground. When the ultimate ground we are talking about isn't a solid core, rather a plasma torch. The difference is
Okay, so we take a look at that, the plasma core.
Preface.
We're going to do more with that as time goes by here. But I'd like to see you guys, get involved and
huge, and has major consequences if we don't adjust what we know to meet the facts of the case at hand. Human-induced problems with Earth's plasma core could have far-reaching consequences. The first step is getting everyone on board with the concept that everything we thought we knew about Earth's core was wrong. An immediate study needs to be done on this topic.
oh yeah. Okay, we can do without that one right there. But we're going to find out too that the Earth's core rotates opposite the mantle, so that the mantle of the Earth and the core are rotating in opposite directions, and the plasma tends to act like a lubricating element. So it's kind of like grease. So imagine a big ball burning in the center, and then a larger ball around that with the solid core, the Earth's core, with the mantle. And then you've got the inner core, the outer core, and then the mantle. We're going to take a look at that here in just a second. But go ahead and let me know what your interests are in these announcements. Let's get back to the main. Yeah, let's do